Welcome to another episode and video on our Raspberry Pi with electronics, partly fischertechnik, and an SPI continuation, serial peripheral interface, with an analog to digital converter, which is necessary to read the analog values of this light dependent resistor and this light dependent resistor to transfer using serial peripheral interface to the Raspberry Pi, which is by itself completely digital. Last time I found that although the program is working perfectly, I got mixed data, primarily zeros and once in a while some data, and using these schematics I have once again added probes, as you can see, to everything. So clock is yellow, this one, then data is this one, and slave select is this one, and as you can see this one is high, but if we go back to this one, CS has a bar over it, which means it is inverted. So in that respect it is still here. So let's see how it behaves. And by the way, this is all output from a system update, nothing shocking. Last time I also commented out the NTC, which is here, because I wanted to see if anything would work. Well, right now you see that nothing is working, not even here. And the question is the oscilloscope set correct? So I am going to change a value. And this is not helping. Now back to 5 volts, and I will select the data, not helping either. Then the select, nothing either. So the question is what to do about it. We put it back to 5 volts. Everything is completely zero. Time base, is that an option? Now there are spikes, but I can hardly call that data. So with this respect, I haven't grounded the crocodile beaks yet, as you can see, so maybe it is a good idea to do that, because this is leading to nowhere. And also one thing is that I have bypassed switches, so there's no need to use those. It should just work. And when I cover this one or both, they're not working. And back in the beginning when I set this whole up, it worked perfectly. So what's the reason? Now, after reading some more info, it seems that the frequency of the SPI is 1 megahertz. That means that I have to change this timing, which I by now have changed from 500 milliseconds or so, 5 milliseconds to 1 microsecond, but still it doesn't do anything. What occurs to my mind as well is that it may be just the port of the ADC that is not correct. So what I'm going to do right now, stop the program and say, alright, let me just for now change everything, comment this out, and then comment this in, and see whatever happens. And LDR value is not known. Yeah, that is this one. And this one doesn't do it. Doesn't do anything either. So let me go step by step and use other ports, because if the other ports are doing nothing either, I may have a very big problem. So let's start by stopping this one, then revert what I just did. Comment out, and then, well, let's just keep it to yeah, this is about NTC, this is about the LDR, which I want to use. Now we're back in business, I think, so let's test. Yeah, the LDR is back. Well, in screen output at least, not in value yet. So what next is that I use this wire, which is doing nothing right now anyway, use to bridge the various ports that this one has. There are 8 ports here, and either one should do anything in result. And then I will have to change it here as well. So 1 is to the NTC, so I'm going to test 2. First I will have to take this wire and put it in here, and hopefully it sticks around. Right, other end of the wire, and I will put this in 2. Now for that to happen I will use another one, because 0 is still in use, but I will use 2. See whatever that works out or happens. No such file directory. Now that is interesting. What about to 0 then? Nothing either. That is interesting. Or am I getting this wrong then? SPI open 00, SPI open 01, which is for the LDR, has no effect. Then I have to get back to my data to find out how exactly this is set up. Good point. Well, despite the information that I found, I think I'm doing okay. And something else that just happened. I set this back to its original setting, 0, 0, saved it, started the program, and what happens? LDR value 3, and then back to 0. So this means that it does work. So why does it work all the time? Is it a coincidence? I really honestly can't tell. So let me start and stop, and here nothing happens, and also here nothing to see. What if yeah, there is a cleanup, that's very important, but then again, if the ADC, which is an MCP 3008, has 8 data inputs, then it does know how 01 goes, but why does it object to 02 if it has 8 reserve pins? Then it should happen, it should work. So that's a mystery to me. Just short runs. And yet as yet no data, as if it was just a coincidence. And that is what bothers me. Why did it work, and why doesn't it work? And yet it did, obviously. So I'm just going to try. If I look right here, this is in the SPI device document. It says right here, port 0, device is 1. Now the device is simple, it is the ADC. That is the device. So or is it? No, it is not, because here it says 1, and it is about, even this one is centered around, no, this one is not centered around the 3008, it's just Python development. So, what's the big deal here? 00 did work, no doubt about it. And going back to here, yeah, unfortunately, well, I should point it out doing it like this, but I have to be aware of all the wires. Alright, be careful. So actually where this is ending with this little wire, that is port 0, and then you have port 1. So that is a device. So then this is a device combined with this one. The NTC is a device. So in that reasoning in that way, you should be able to say, alright, then I have a channel 0 device 2. And I should add here, let's say, LDR channel 2 is 2. So then we say SPI dot open 0.2. And then also say because I have two LDRs, so I could do that as well, just make it a second LDR channel, not combine them on one but separating them. I think that would be a very nice idea. Why didn't I think of that before? I think that, yeah, I think I'm going to do that. I changed the circuit a bit, in the sense that now, as I said, two LDRs, now they are not in series anymore or anywhere else, now they are now separate. And I moved the switches like this one, which is press to make contact. If not, contact is not made. And this is the 10k resistor. Let's see. This is the 10k resistor, 10 kilo ohms. then the switches, then the wires. It is hard to see from the camera point of view, but the wires are such that they are not connected to the resistor in open situation. So whenever I press a button, then that particular LDR is connected and should be able to read out, provided of course that this coder will work. And then I will have two separate LDRs. The problem is that I have only one 10 kilo ohms resistor, so then you have to improvise. Now here is hoping that it will work, and number 2 is not working out, which is in this case this one, and that is a bummer because it is connected to the second, in this case the third pin. So if I change this to 3, which is the fourth pin, which is not connected right now, will that do anything? No, because it says no such device. So what do I need to connect it? Well, let me first now comment it out, then leave it at 2. Then I will also will have to leave everything else out, but let's just see whatever happens, and I only can press the button, the black button, which refers to this small LDR. But let's just see whatever happens. Alright, now you see these LEDs blinking. That is still from the software pulses modulation for the LEDs, but now I want some value. This is not working, and this isn't working either, unfortunately. So let me quit and start again, hopefully to get some value. But as yet, nothing. Totally nothing. Which brings forward once again the question, why does it give just a value and then quits doing so? Because if it was broken, there would be no value at all. And the probes are still connected, so that's not a problem. They are connected to mass. And it gives no value at all. So what's next? Nice idea, but apparently it doesn't work out. The last few things I have done is setting a max clock speed to count 11 megahertz. 11,350,000 hertz. Now if I look here, that is not the same, but then again, if I get all zeros, then it wouldn't matter. What I've also done is on advice, and you can find the sources of my info in my blog on my website with the exact reasoning behind it, and in that same sense raw data printed here. So, and why is it printed twice? Because I have printed it twice, and that doesn't matter. It's for 1 and 2. Anyway, with that, this doesn't work out yet. Now in this case I have to press the button for a nice value, provided it does give a nice value. And as yet unfortunately that doesn't happen. So let me then go back to the oscilloscope and change the timer setting. So now it is 1 microsecond, half a microsecond, and I'm at a limit of 5 nanoseconds. Is that good or is that bad? 100 nanoseconds. Let's just keep it at that. On the other hand, 0 is 0. Nothing coming out of it. And oh yes, I still have to press the button to see anything. And it's still all 0, so let me print this out, comment this out. And which is which? This is still the 0 one, so this one doesn't matter for now. Let's just keep it spared and continue. And this is still the LDC that matters for now. And I wish I did not block everything, so let me do it right now. Still all 0. Covering up. Does it really matter that way? Or do I make a serious mistake? Let me think about it. So this one goes from here to here. Then from the inside to there. This one is connected here and goes from the inside to there. So that is all the same. Yeah. No wiring error that I know. And still, apart from that one value 3 that I got, nothing else. And I know that this wiring is correct. So I'm still very much in the dark of what is going on. And I don't like that, but I'm not giving up. Given the fact that I did get the value, also means that the ADC is correct. So if I would have had all 0, only 0, then I could have said, right, it's broken, but that's not the case. Anyway, that's it for now. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up, like it. Follow me on Instagram and like it, and follow me on Twitter, retweet and like. Please donate to keep the video coming your way. More information, please see my website, and also my other projects are on the website, as well as a lot of pictures. And this is to be continued, obviously. So bye bye.